Yeah, good evening, Naveen. I hope you are able to see the screen and my voice is also audible properly. Can you please confirm me that? Are you able to see the screen and is my voice audible properly?
Hello, sir. Can you hear
Yeah, yeah.
me?
Yes.
Good evening, sir. It's
Yeah,
clear.
yeah,
Screen
yeah,
and your
fine.
voice is clear.
Yeah, fine. Thank you. I request you to please be on mute. So whenever you have a doubt or whenever you have a question, you can unmute yourself and then you can ask the question.
All right, sir. Sure.
Yeah, thank you. Fine. So in the last class, we were talking about the concept related to the cement. So mostly whatever the discussion that happened in the last class, we have seen how the concrete structures has got evolved over a period of time and what is the history of a cement, and then who is called as the father of civil engineering, and then who invented the cement. And then we have seen the raw materials that are required to manufacture the cement. That is, there are two raw materials that are required on a large scale. One is called as calcareous materials, and the second one is called as argillaceous materials. And then we have seen this manufacturing process of the cement in the real-time scenario. There, I have shown you a couple of images which explained about how the cement industries will work in order to produce the cement. And then we have seen the two different process of cement manufacturing. One is called as the dry process, and the second one is the wet process. And then we have also had a question that why it is important to add gypsum into the cement manufacturing units. And then we have discussed about what is its importance and why it is required to add the gypsum in the cement. So that is where we have stopped in the last class. So in today's class, we are going to focus on two different aspects. One is we'll be looking towards the classifications of the cement, and then the second one is we'll be looking towards a concept which is called as a hydration of cement. So these are the two things that we are going to focus in this particular session. So coming to the first topic, which is the classification of a cement. So on a large scale, suppose if you talk about the cement classification across the globe instead of India, first we'll talk about on a global level and then we'll narrow it down to the Indian level. So on a global level, the cement classification has been there in different ways. One is based on the ASTM standards, which is called as American Society for Testing and Materials. That's the first type of cement classification or the first classification of the cement. And then the second category is based on European industry, that is called as European norms, EN, we'll just call it as. And the last one is basically on Indian standards, which is called as BIS, that is Bureau of Indian Standards. So if we have to classify the cement across the globe, then these are the three major classifications of cement that is available. Yes, we do have other classifications also, but mostly we'll go with ASTM standards or European standards or the Indian standards. So we have the British standards, we have other types of standards also, but let us not focus on all of those things. So first, let me talk about what are the different types of cements that are available with respect to the ASTM standards, that is American Society for Testing and Materials. So if we talk about ASTM classification of the cement, we have different types of cements. In this case, we are having a cement which is called as a type 1 cement. Okay, in ASTM, we don't have a specific names to the cement, but they used to call the cements by using the type 1, type 2, type 3 likewise. So the first one is called as a type 1 cement. It is basically a normal cement. So if you want to correlate that type of cement with Indian standards, it is basically an ordinary Portland cement. OPC represents ordinary Portland cement. But remember, so type 1 normal cement is the cement that is available there. So if you go to US and if you ask them, can I get the ordinary Portland cement? No, they will not understand what exactly is you meant by OPC. So you have to talk with respect to their standards. And again, the same thing applies for Indian standards also. You cannot go to a shop and then you cannot tell that I need type 1 cement. So you need to be specific according to the standards that are available in that particular country or in that particular geographic location. So that's the first type, which is called as type 1 normal cement. And then we also have the type 2 cement, which is called as moderate sulfate resistant cement. Okay, type 2 cement in US standards is basically a sulfate resistant cement. Again, it's a moderate sulfate resistant cement. And then we have the third one, which is called as type 3. And that cement is called as a high early strength cement. So in Indian standards, we can call that as a RHC. That means a rapid hardening cement. So we'll talk about RHC, OPC things once we go to the classification of Indian standards. But since we are with ASTM standards, let us just focus on type 1, type 2, type 3. And then we also have the next one, which is called as type 4, which is a low heat cement. So the cement which produces low amounts of heat during the hydration process, that cement is called as a low heat cement. And then we have the last one, which is called as a type 5, which is a high sulfate resistant cement. So type 2 is moderate sulfate resistant cement, and type 5 is a high sulfate resistant cement. Okay, that is also called as SRC, that is sulfate resistant cement. So these are the 5 major classifications of cement that we have according to the ASTM standards: type 1, type 2, type 3, type 4, and type 5. But again, in type 1, type 2, and type 3, we have the sub-classifications. So coming to type 1, we have one more classification, which is called as a type 1A. Okay, type 1A. So type 1A basically consists of mix of two different cements. One is a normal cement, and the second one is it also consists of certain kind of air entrained agents. So I'll talk about what is this air entrained agents when we are talking the admixtures topic. So I'll discuss that there. Okay, but for time being, just remember that in type 1 we also have one more category of cement, which is called as type 1A, which is a mixture of a normal cement along with the air entrained agents. Similarly, in type 2 we also have one more category, that is called as type 2A, which is a mixture of sulfate resistant cement plus air entraining agents. So air entraining agents are common in both type 1A and type 2A. Similarly, we have the type 3A, which is again a combination of air entrained agents with the higher strength cement. So on a whole, these are the 8 different classifications of cement that is available according to the ASTM standards: type 1, type 1A, type 2, type 2A, type 3, type 3A, type 4, and type 5. So on a whole, we have the 8 different classifications of cement. Sorry, not 8. Yeah, 8 different classifications of cement that we have. Now here, if you ask me, do we need to bother about all these ASTM classification? I would say no. There is no point in understanding, or there is no point in knowing about all these types of cements until or unless if you are from, or if you are somebody who is going to work in US, or if you are somebody who is going to work in countries where they are following ASTM standards. Until then, it is not important. But just for our understanding, it's important to know, or it's good to know. And here, one thing which we need to know is in any cement, we'll have four major components. Okay, that is C3S, C2S, C3A, and C4F. So I'll talk about these compounds once we start talking about the hydration topic. But for time being, what you can remember is these C3S, C2S, C3A, and C4F are the components of that are available in the cement. Okay, these are the components that are available in a cement, and these components are called as a Bogues compounds. Okay, all these four compounds are called as a Bogues compounds. Anyways, I'll have to discuss much detail about Bogues compounds in the later case, but time being, let us just stick to this point. So you can see that in type 1, type 2, type 3, type 4, and type 5, the classification or the composition of the Bogues compounds in each different type of cement. So based on the change in the Bogues compound composition, the cement classification will get changed. Okay, for type 1, we have a different composition of the Bogues compounds, and for type 2, you have some other different composition. So based upon the composition of C3S, C2S, C3A, and C4A, the type of the cement will get changed. Okay, the type of cement will get changed. But here, one thing which we need to focus on is the type 3 cement. Okay, type 3 cement. So what is this type 3 cement? Basically, type 3 cement is the high early strength cement. That means it is the cement which attains strength at the early days itself. Suppose if you talk about a cement, if you want to get a strength to the cement, you need to wait for 28 days. Okay, if you want to get proper strength to the cement or target strength to the cement or concrete, you need to wait for 28 days. Now, in certain constructions, we might not have time to wait for 28 days. The best example is during COVID time. So many number of hospitals have been constructed just for the purpose of keeping the patients in the centers, right? The COVID treatment centers. Now, in that time, what they happened? They have constructed in the Indian scenario, it happened at a very small level or a small scale level. But when you talk about the at China level or even at US level also, they used to construct the buildings by using concrete only. Here we started constructing the buildings by using the sheets, by using the GI sheets, that is steel sheets. But they started constructing the houses. They started constructing a very big auditoriums by using concrete itself. So how that concrete structures? Have they waited for 28 days of time to ensure the concrete to get set? No. So in such cases, they have used a special type of cement, which is called as a high early strength cement. So when you use a high early strength cement in the concrete construction, you don't need to wait for the typical or conventional 28 days. Okay, the concrete will attain strength within 1 hour, within 2 hours, within 10 hours. So it depends on what type of cement that you are using. Okay, so there is this one strength, one type of cement which is called as early strength cement or high early strength cement. So the why it is able to attain the high early strength to the cement is one possible reason for that is it consists of too much amount of fine particles. Okay, too small type of fine particles are available. Whenever the fine particles are there in the concrete, or sorry, whenever the fine particles are available in the cement, it leads to more amount of heat of hydration. Okay, whenever you can see here, the higher the fineness, the more is the heat of hydration. Again, hydration we need to discuss, but just for understanding, I'm telling. So whenever you have the fine particles in the cement, it leads to more amount of hydration, but along with the hydration, it leads to higher strength at the initial days itself. But there is one problem with such kind of things. The problem is thermal cracks will happen. So cracks will happen on the surface of the material or the surface of the concrete. Anyways, we'll talk about these things once we discuss more clear about the hydration process. But this is how the classification of cement that goes based on the ASTM standards. Now let's talk about the classification of cement based on again the ASTM standards, which are called as blended cements. So what is this blended cement? Basically, blended cements is one type of cement which is a combination of general cement, okay, general cement plus any kind of mineral admixtures. Okay, any kind of mineral admixtures. Suppose if you remember the mineral admixtures available in the market, we have the silica fume, we have the ground granulated blast furnace slag, we have the rice husk ash, we have the fly ash, and then we have couple of other things also. So when you mix a cement with the mineral admixtures, such kind of cements are called as blended cements. Blend means mixing of two different materials in the cement. Okay, mixing of one or two different materials in the cement. Such kind of cements are called as blended cements. So in India, we have a different type of cement which is called as PPC. That is a Portland Pozzolana cement. And we also have one more type of cement called Portland slag cement. So in PPC and PSC, what actually will be there is it will have the cement content, that is original cement content will be there, which is ordinary Portland cement. Along with ordinary Portland cement, certain amount of fly ash will be added into the cement. So such kind of cement is called as PPC, that is Portland Pozzolana cement. And we have one more type of cement in India, which is called as Portland slag cement, where we are going to add certain amount of slag content into the cement. So that's where we have the different types of cement, and those cements are called as blended cements. So blended cements are the cements which consist of multiple materials or multiple mineral admixtures in the cement. Maybe we cannot say it as a multiple, maybe one or two mineral admixtures that can be available in the cement along with the ordinary cement. Similarly, along with the ASTM standards, we have one cement which is called as Portland blast furnace slag cement, which is called as type 1S. So what does actually consist in this cement? So it consists of the ordinary Portland cement, that is type 1 type 1 cement. You can see here. So type 1 cement will be there. So what is type 1 cement? It is basically a normal cement or a conventional cement. So along with the conventional cement, we will also have one more material which is called as a slag. Okay, which is called as a slag. and hence the slag is available at a different proportion varying between 25 to 70% by mass. Suppose if you take one cement bag is almost 50 kgs. Okay, in India, it is one cement bag comes with 50 kgs. Now, in that 50 kgs, 25 to 70% of the entire 50 kgs can consist of a slag. Again, that relates to ASTM standards. So slag will be available at a range of 25 to 70% by mass. It can vary between any value between these values. Okay, so such kind of cement is called as a type 1S cement. So here, what does S represents? S represents it's a slag cement. Okay, type 1S. Type 1 is a normal cement. So when you add slag to the cement, it is called as a type 1S. Okay, it is because it is mixed with the slag. So now the question is why slag is added? Okay, that's one thing, because just like that, we cannot add any material and we cannot call that cement as a blended cement. So we need to be specific about the properties of the material. Suppose here we are adding slag, but why we are adding slag? What is the importance that we get, or what is the advantage that we get with the addition of the slag? So the answer for that is slag will have a capacity to react with the cement on its own. Okay, the slag will have a capacity to react with the cement on its own. Though it's a longer process, or though it's a time-consuming process, it's very good to have such kind of materials in the cement. Now, again, the one more reason for that one is, suppose if you talk about the, if you talk about the carbon dioxide emissions with the cement manufacturing units, so you will have almost 7 to 8% of carbon dioxide emissions that happens in the that happens during the production of the cement. That statistic we have discussed in the last session. So 7 to 8% of carbon dioxide emissions will take place with the production of cement. Now, when you add these kind of materials such as the slag, the fly ash, all these kind of materials, what happens? So you can reduce the amount of carbon dioxide emissions. Okay, you can reduce the amount of carbon dioxide emissions. So that way we are benefiting the environment, and at the same time we are benefiting the construction industry as well. Okay, that way we are benefiting the environment factors by reducing the carbon dioxide emissions, and we are also reducing the we are also enhancing the properties of the materials with the use of different quality of cements or different types of cement. That's one scenario. And we have one more type of cement which is called as Portland Pozzolana cement. It is called as a type 1P. Okay, it is called as type 1P. You can see here, P represents a pozzolanic content. Usually the pozzolanic content that is available in the ASTM standard cements are 15 to 40%. Even in Indian standards also, we call it with the same name, that is called as PPC. So nowadays, most of the construction companies or most of the construction sites have been using only this PPC only. Okay, we stopped using the ordinary Portland cement because in ordinary Portland cement, we will have only the normal cement. So we know what happens. Yes, we have the advantages to use only the ordinary Portland cement. So there is no doubt in that. But there is also a problem with that. That is carbon dioxide emissions. So we don't want too much amount of harm to be caused to the environment just by the production of cement. So in that case, we need to go with the alternative materials, and those alternative cements are called as a blended cements. So again, I'm repeating the statement. The reason why we are going for the blended cements is to reduce the carbon dioxide emissions. That's one scenario. And to modify the cement properties also. Okay, to modify the cement properties also. Again, the question comes with why we need to add pozzolana, because pozzolana again reacts with the cement in the presence of water, which again gives the same type of strength or enhanced strength to the cement. So these are the two types of blended cements that are available according to the ASTM standards, right? So on a whole, how many types we have now? So there are 8 general cement classifications and 2 blended cements, type 1S and type 2S, type 1P. So that means on a whole, we have 10 classifications of cement or 10 types of cements that are available according to the ASTM standards. Maybe now they might have increased it to a couple of more. I have not verified with this one, but this is something which is standard one. Okay, fine. So now let's look at the different types of cement based on the European norms, that is EN. So in EN, we don't have something like type 1, type 2 like that, but we have the norms such as the SEM1, SEM2, SEM3, SEM4, and SEM5. CEM represents cement. Okay, CM1, CM2, 3, 4, and 5. So you can see the description of each cement. So CEM1 talks about it's a Portland cement, that is general Portland cement, that is ordinary Portland cement. And CEM2 is something like Portland composite cement. That means it consists of certain additional materials. And CEM3 is blast furnace cement. That means it consists of certain amount of slag in the cement. And CEM4 is something which is called as pozzolanic cement. That is pozzolanic material will be added, which is basically the fly ash will be added. And CEM5 is a composite cement which consists of large amount of mineral admixtures. Okay, you will have more amount of mineral admixtures here. That is, it can be silica fume, it can be fly ash, it can be GGBFS, it can be rice husk ash, anything. Okay, so these are the classifications of cement according to the European standards. Now let's jump into the real thing, which is the classification of cement according to the Indian standards. That is a BIS, Bureau of Indian Standards. So if you look at the classifications, we have the first type of cement, which is called as ordinary Portland cement. And then we have the type of cement called PPC, that is Portland Pozzolana cement. We also have the Portland slag cement, rapid hardening cement, extra rapid hardening cement, sulfate resistant cement, quick setting cement, low heat cement. So these are the different cements that we have. Here I have just mentioned the major ones, but we also have other types of cements also. But anyways, so these are the most important things that we need to focus on. OPC, PPC, PSC, RHC, ERHC, SRC, QSC, and LHC. These are the different types of cements that are available in the Indian context or in the Indian scenario. Suppose if you take any cement bag, on the top of cement bag, you need to observe. Suppose whenever you go and buy the cement bag, you cannot just, we cannot just go to the cement manufacturing unit or the cement retailer unit, and then we cannot just blindly get the cement bag. So we need to be very careful in buying the cement bags. The first couple of things that we need to look for is whether there is an ISI mark that is available on the top of cement bag or not. That's the first thing that we have to look for. So if you have an ISI mark on the top of cement bag, that means it's an authenticated one. Okay, it's a government approval was given for this type of cement. That's one thing which we have to look for. And the second thing is the quantity of the cement bag. You can see on any cement bag, this will be mentioned, the net quantity. You can see 50 kgs. So in Indian context, we'll get 50 kgs as the cement bag. One cement bag consists of 50 kgs of cement. And a couple of other things which we need to look for is the type of the cement. You can see here ordinary
Hello, sir. Sir, your voice is not audible, sir.
Yeah. Yeah. So coming to the Indian types or Indian classifications of cement, these are the things. But as I was discussing in the previous thing, what we need to focus on is the type of the cement that we are using. So what is the type of cement that we are buying? Suppose if you go to a cement shop and if you ask that you need ordinary Portland cement 53 grade, but if they give OPC 43 grade, that represents a decrease in the strength. So here numbers 33, 43, and 53 represents the strength of the cement at the end of 28 days. Okay, 33 represents 33 newtons per mm square strength will be there for that cement. 43 represents 43 newtons per mm square of strength will be there for that cement. 53 represents 53 newtons per mm square of strength will be there. So in OPC, we have three different classifications: OPC 33 grade, OPC 43 grade, and OPC 53 grade. So nowadays, we are not getting the OPC 33 grade of cement. So it's an outdated one because of its low strength parameter. And nowadays we are getting, we almost stopped getting OPC 43 also. So we have, as per my knowledge, currently we have OPC 53 grade of cement, which is the cement that gives 53 megapascals of strength. Okay, that is 53 newtons per mm square and 53 megapascals of strength. So that's one thing which we have to look for. Okay, the type of the cement that we are getting. So here it is OPC. So in some cement bags, you will have the PPC also. In some cement bags, you will have the PSC also. So you should be very careful in identifying the type of the cement, because you cannot use the same types of cement for all kinds of construction. Suppose let's say you cannot use the quick setting cements for the construction of a G+2 building. Okay, what happens with the quick setting cement? The cement will set at a very fast rate. So when the cement is getting set at a very fast rate, you will not be having enough time to transport the cement. So that's one problem. So you have to be very careful in identifying the requirement of the cement based upon the type of the construction that you're going with. So that's where the importance of looking on the top of cement bag, whether it is the type of cement that you are looking for or not. That's one thing. And the second thing is we need to look for the manufacturing date and year of the cement. Okay, you can see at the bottom. So you'll have these three boxes on the type on the cement bag, which indicates the week, month, and year. That means in which week it was manufactured, in which month it was manufactured, and in which year it got manufactured. So you'll get all these details. And if you check at the backside of the cement bag, or sometimes if they will represent at the bottom itself, for how many months you can store this cement bag. Okay, for how many months you can store the cement bag. If you store beyond that, then the cement bag will go outdated and you cannot use such kind of cement for the construction, because cement will lose its properties if you store it for a more duration. So these are the couple of things that we have to look for when we are buying a cement bag, right? So now let's talk about the each type of cement. So the first one is ordinary Portland cement. So as I was telling, it is the most important type of cement, and it is also one of the most commonly used type of cement. That's what widely used type of cement. And it is suitable for all kinds of concrete construction. Whatever the structure that you are constructing, be it a G+2 building, be it a multi-story building, be it a G+10, whatever the type of structure, the common cement that we generally go for is ordinary Portland cement. Now, here in the ordinary Portland cement, we have three different grades. As I was telling earlier, we have OPC 33 grade, OPC 53 grade, OPC 43 grade, and OPC 53 grade. So these are the respective code books for each grade of cement. Suppose if you open IS 269 1989, it talks about the classifications of the 33 grade of cement. If you open or if you Google this particular code book, you will get the details that are related to OPC 43 grade of cement. Similarly, IS 1226 about specifications related to the OPC 53 grade of cement. So here, what we need to understand is what are these numbers talks for. So as I said earlier, these numbers talks about the strength of the cement. So ordinary Portland cement of 53 grade, you are going to get 53 megapascals of strength to the cement. Okay, 53 is a good one. Again, it is the strength of the cement, not the strength of the concrete. Concrete strength is different from the cement strength. Okay, so but in general, we will go with OPC 53 grade of cement only, because obviously people will expect, or the clients will expect us to give better strength to the structure. So if you are an engineer or if we are an engineer, so if you get some clients, if you ask them, do you need low quality structure or the high quality structure? Obviously, any client would say that I need high quality structure with better strength. So that's where we'll go with OPC 53 grade of cement in general case. So all the grades are produced from same basic materials. So there won't be any change in the basic materials. But what increases or what makes the change is the materials that we use. Suppose here you can see by increasing, you can see, but higher strength is achieved by increasing the tricalcium silicate content, that is a C3S content. Okay, when you increase the C3S content, it will make sure the strength will have, the cement will have the highest strength. So what is tricalcium silicate? That I'll talk in hydration process. But here I'm just going it on a plain level because there is no thing that needs to be discussed on a large scale with respect to the types of cement, as I expect that you know. So since you're not a beginner to the types of cements, all these things, so I'm just going it on a covering with most important specifications with respect to the all types of cements. So that's how the ordinary Portland cement will looks like. It's generally looks like in the form of an ash color or light ash color, you can say, or gray color also you can say. Okay, so that's something which is respected to ordinary Portland cement. But here we need to work on one important thing, which is called as performance improvers. What are these performance improvers? Suppose let's say you want to improve the performance of a material. Suppose, let's say you are a mechanical engineer and you are running one machine. Let's say you are running a turbine. Now, if you want to increase the performance, let's say you have not oiled or you have not applied the grease for the instrument for the last 1 year or 2 years. Due to COVID time, you have not applied the grease or oil part to the machine. Now, after COVID lockdown is completed, you just came the next day, and then if you run, are you going to directly run the machine? No, we cannot run the machine directly. So first we need to apply certain materials on the machine. That is, we have to apply the grease, oil, all these things. And then we have to wait for some time, and then we have to run the machine. So why we are doing that? We want to increase the performance of the machine. Similarly, in cement also, we have the materials which are called as performance improvers. So what are these performance improvers? In general, we'll use up to 5% of performance improvers in the cement. Okay, we'll use up to 5% of performance improvers in the cement. But again, are there any special materials such as performance improvers? Yes, we do have. I'll talk about that. So limestone is one of the performance improvers, and fly ash is also one of the performance improvers. So these two will improve the performance of the material. Okay, performance of the cement, you can say it as. So if you add up to 5% of limestone, additional limestone will be generally available in the cement. Okay, apart from the general availability of the limestone, if you add additional up to 5%, maybe you can increase up to 10%, 1%, you can go up to 2%, 3%, 4%, and 5%. But beyond 5, it is not suggested. So up to 5% is the maximum content that you can add the performance improvers. So the reason why we are adding the performance improvers is to reduce the energy consumption and to reduce the cost of the production. That's one thing. And the second thing is they also reduce the carbon dioxide emissions. And the is how they are added. Once the cement is prepared, are you just going to keep some material, keep some limestone or fly ash in the cement bag? No, it is not in that way. So during the production of cement itself, okay, when you are burning the limestone or when you are grounding the limestone into your fine particles, in that stage itself, you need to add these performance improvers. That is where we'll get the PPC cement, Portland Pozzolana cement. So they are not going to add fly ash once after the entire cement is manufactured. So they will add during the burning process or during the grinding process of the cement materials itself. During itself will add the performance improvements, and hence the performance will get better so that we'll get different type of cement, and hence we can reduce the energy that is required to produce the cement, and we can also reduce the cost of the cement as well. Okay, we can also reduce the cost of the cement as well. So suppose if you take the example of ordinary Portland cement and Portland Pozzolana cement, the ordinary Portland cement will come with approximately 500 rupees. One bag of OPC is 500 rupees. But whereas PPC, one bag of PPC is approximately 430 to 450 rupees. So you can see the change in the cost. Okay, why the change in cost is happening? Because some additional materials are being used. And again, these are not the materials which we prepare. These are naturally available materials. Fly ash is something which is naturally available material. Anyways, I'll talk about those things in the admixtures. In detail, we have to understand about those materials. So that's the reason why we go with the performance improvers. And the next type of cement is PPC, which is Portland Pozzolana cement. So this is the standard code book that you can refer in order to get the details or specifications of the PPC. So you can see on the cement bag itself, Portland Pozzolana cement, and you can see in the brackets, it is a fly ash based. So Pozzolana is something here is fly ash. So they will add a certain amount of fly ash to the cement. Okay, they'll add certain amount of fly ash to the cement. So up to how much content? Up to 5%. That's what performance improvers we were looking at. So in performance improvers, we'll add fly ash also as one of the performance improvers material. So here we are going to add up to 5%. Beyond that, we cannot add. Okay, so that's where the Portland Pozzolana cement will come into picture. Which is a siliceous that means it contains a certain amount of silica materials, or it can also contain the silica material along with the aluminous material. Okay, it can contain any one. Maybe it can contain only silica material, or it can contain silica material as well as alumina material. So such kind of cement, when you add these products, it is called as a pozzolana. And that is why we call it as Portland pozzolana cement or Portland pozzolana cement. So the pozzolanic materials used in the manufacturing of PPC are generally classified as one is clay, that is calcined clay, and the second one is the fly ash. That's one type of cement, that is PPC. So here, in the past, we used to go up to 25% replacement of cement clinker by calcined clay, but nowadays almost all PPC in India, which is produced with fly ash as a pozzolanic material. So we don't have any kind of calcined clay that is being added. So as I was telling in the beginning of the class also, so we have got the PPC cement where most of the construction companies have adopted to this particular type of cement, that is PPC cement. Yes, it does have the better properties, it does have the better indications to the concrete strength, everything is fine there. So that's why people started using this PPC cement. Okay, but nowadays we are using up to 35% of fly ash in the cement. It is no more the 5%. So it has been proved that we can increase or we can go up to 35% in order to we'll go with 25 to 30%. That's the standard value you can say. So it has that is PPE has high risk various chemical attacks on the concrete. So if you don't chemical attacks to the concrete, so PPC will have the resistance to the different chemical attacks to the concrete. So that's one of the advantages with the PPC cement. Okay, and it gains strength relatively very slow when the OPC cement, but it needs more curing time. Okay, it also needs more curing. That's only the use PPC for any general type of cement, that is for any ordinary Portland cement, you will get the strength at the end of 28 days. Okay, at the end of 28 days, you will get 99.9% of the target strength. But when you use PPC, you will not get your target strength at the end of 28 days. You will get your target strength at the end of 56 days. Okay, at the end of 56 days. That's the only thing which we have to remember here. So that is what it says. It gains strength relatively slowly, and hence it needs more amount of curing time. So that relative slow duration is 56 days. Okay, so when you use PPC in the construction, make sure you are going to do the curing process for more than 28 days. Maybe you should go up to 40 or 45 days also. It's better if you go up to 56 days, but at least 40 to 45 days is something which is required for us. That's something which we have to remember. And this cement is preferred where time is not of importance in the construction sites. So if you can go, suppose when the structures are constructing like the roads, the bridges, all these things, so the roads and bridges, they cannot be constructed just in 2 months or 3 months of time. So they'll take for years. So the one reason why they take years and years of time is the type of the cement that they use. Since in those cases they use PPC cement, what happens is PPC will take more amount of time to attain the strength. It takes 56 days of time. That is almost double time. So usually it takes 8 days. So 56 days. That means instead of waiting for 1 month, you have to wait for 2 months to cure the concrete. So that's one of the reasons why again, that's one of the technical reasons. Again, it is not something which is the other reasons. When you talk with respect to the technical standards, so that is why these large scale construction activities will end years of time. So that's something which we have to understand. And then the next type of cement is called as a Portland slag cement. Okay, you can see on the top of the cement bag, Portland slag cement. JSW is one of the leading manufacturer of the Portland slag cement. Okay, even in my laboratory with my students, even I'll suggest the students to go with either PPC or PSC only. I'll not suggest them to go with OPC cement because OPC is, yes, it is currently ongoing only. It is not an outdated one. But again, the problem with OPC is more amount of carbon dioxide emissions will take place during the production process. So there is a requirement to shift towards the other types of cements that are available in the industry or that are available in the market. So that's where I'll to go with either PPC of additional materials such as slag or fly ash. So these are the couple of details related to the slag cement. And here, a couple of things which we need to remember is the 25 to 70% of slag can be replaced in the cement clinker. Okay, in the place of cement clinker, we can replace up to 25 to 70%, and slag is basically the GGBFS, that is ground granulated blast furnace slag. Ground granulated blast furnace slag. That is what GGBFS indicates. So this GGBFS will be obtained from the iron industries. So iron manufacturing units, we are going to get this GGBFS. Anyways, I'll talk more details about GGBFS in the admixtures concept. But here, a couple of things that we need to understand is the initial strength will be very low when you compare with the ordinary Portland cement. Due to this, it cannot be used in the RCC works. Okay, the Portland slag cement will have very little strength in the initial days. But again, at the end of 28 days or at the end of 56 days, it has enough amount of strength. And the advantage of using the Portland slag cement is it is resistant to sulfates. Okay, it is resistant to sulfate. What is the advantage of Portland Pozzolana cement? It is resistance to chemical attacks. Okay, if you see here, so Portland slag cement, it is something which is good to avoid the chemical attacks. Okay, chemical attacks. It reduces the chemical attacks. And this one, you can see here, high resistance to chemical attacks. That is with PPC. The advantage of PSC is it reduces the effort, or it reduces the, or it gives the resistance towards the sulfate attacks. Okay, we have this thing called sulfate attacks. We'll be talking about this one in the last but one unit. So that is in the fifth unit, we'll be talking about these ones. Okay, so that's something related to the Portland slag cement. And then we have the next type of cement, which is called as a rapid hardening cement. You can see on the top of the cement bag, rapid hardening cement. You may not be able to see the exact rapid word here because of the crunch of the cement bag, but you can see hardening cement. So it's basically a rapid hardening cement. So the advantage of going with rapid hardening cement is it sets or it gets hardened very fast. That is what rapid. Rapid means very fast. So it develops strength very rapidly. You can see the strength of rapid hardening cement at 3 days is equals to the strength of ordinary Portland cement at 7 days. What does that equation indicate is whatever the strength that you are going to get at the end of 7 days, when you use OPC, the same strength you will get at the end of 3 days when you use PPC, when you use RHC. So that's the thing. So the strength is same, but you can see the difference of age. This RHC is able to get the strength within 3 days only, but the same strength it is taking, the ordinary Portland cement is taking 7 days. Now you can define yourself that where in which kind of constructions will go with rapid hardening cement. Suppose when you are constructing the structures in the mid-sea or in the rivers or in the river shores, there we have continuous amount of water will be there. So when there is continuous amount of water, you cannot keep the concrete in the wet state, or you cannot keep the concrete in a semi-wet state for a longer duration of time. So in such cases, you want the concrete to get set at a very fast rate. So if you want to set the concrete at a very fast rate, so this is something which we can go. Okay, rapid hardening cement, where it attains the strength at a very fast rate. And this is one type of cement that could be used during the construction of the COVID centers. Okay, I was talking about how the COVID centers has got constructed within 5 days, within 10 days. It is because they have used this rapid hardening cement. Okay, they get the strength at very fast. That's where this equation talks about. And we have one more type of cement that is called as extra rapid hardening cement also, that I'll discuss in some time. So you can see rapid strength is basically due to the higher fineness. The more the fine particles in the cement, the more will be the strength. So logically speaking, we have high amounts of C3S content and C2S content. That is what I was talking with type 3A cement also. So when I was talking about ASTM standards, I was talking about type 1, type 2, type 3, and type 3A. So in type 3, I was telling that it contains higher amount of fineness. What happens with higher amounts of fineness? Higher the fineness of cement, higher will be the strength. Or rapid rate will be the increase in the strength. So how that rapid rate will happen? One is with the fineness of the cement, and the second one is with the C3S and C2S content. Okay, so that's something related to the ordinary rapid hardening cement. So this is mostly used in the repair of the roads. Again, this is a CC. This is not a CC road. This is a bituminous road. But again, just for understanding purpose, I want to show this one. Suppose whenever there is a visit, like the MLA visits or the CM visits or the PM visits in a particular district, overnight they will construct the roads, or overnight they will make the roads. Okay, how they are going to make the roads? So they are going to use these kind of cements in the making of roads overnight. Again, they will not give the, I mean, if they will be laid just for as a cover purpose, okay, just for covering the pits, just for covering the dumps in the concrete roads, they'll just make it. But if you don't make it in a proper way, what happens is, again, after 1 week or 10 days, the bridges will get collapsed or the roads will get destroyed. That is what happened. So there are a couple of videos that has been resurfacing on the social media platform, where in UP recently the Prime Minister has inaugurated a bridge. And then after construction of this bridge, maybe, I mean, after it is open for the traffic, maybe after 1 month or 2 months, if I'm not wrong, the bridge has got cracks on the surface. Okay, the surface of the bridge has initiated cracks. Why? It is because of the poor workmanship or the poor quality of the materials that they have used. So in such cases, we'll go with rapid hardening cement, and then rapid hardening cement is also used for the fast scale construction of the structures. Okay, fast scale construction of the structures. So, and then it is also used in the places where we'll have high amounts of snowfall or high amounts of water. So whenever you want to construct a bridge in the middle of the water, you will go with this kind of cement, that is rapid hardening cement. And the next one is extra rapid hardening cement. You can see on the top of the cement bag, ERC, extra rapid cement. So again, in this one, we have the calcium chloride content. Again, it should not be greater than 2%. Along with calcium chloride, we also have the rapid hardening cement inside this. So that is when we call it as an extra rapid hardening cement. And this type of cement should be transported, placed, and finished within 20 minutes. So if you make the duration of the transportation and placing the cement beyond 20 minutes, the cement will get set. Once the cement is set, there is no option to get back the original state. So you can see the rate of attaining the strength to the cement. It is just taking 20 minutes of time only. Okay, so this cement should not be stored for more than a month of duration because of its special properties, and a large quantity of heat will be evolved in a very short time during the placing of this concrete. Again, heat process we need to discuss. That is where we'll talk about the hydration process in some time. Okay. So, and then the couple of other cements, I'll just skip through a couple of points here. That is sulfate resistant cement, and you can see a couple of details here. And if you want to understand more details about the different types of cements, you can refer this particular code book. Anyways, I told in the last class that I will be sharing these code books. I mean, this textbooks. I'll share this after the end of this particular session. You can have a look. So in chapter 2 talks about the different types of cements that are available. If you want more details, there are many YouTube videos and many Google sources also available, which talks about the importance of each type of cement. But if you want a standard one, you can refer this textbook called Properties of Concrete by A.M. Naivalli. In chapter 2, you will have the details related to the different types of cements. That's something. And then let us focus on the next topic, which is called as the chemical composition of the cement. Okay, as of now, we discussed about the cement manufacturing process, the types of cements, all these things. Now let's talk about the chemical composition. So suppose if you take the chemical composition of the cement, basically the raw materials which we use are lime, silica, alumina, and iron. These are the major raw materials. That is calcareous materials and argillaceous materials. Calcareous materials such as limestone and chalk, and argillaceous materials such as clay and shale. But keeping them aside, the major raw materials that are used for the cement manufacturing is limestone, that is lime, silica, alumina, and iron oxide. These are the four major raw materials. Now, when these four major raw materials, okay, when these four major raw materials are mixed with the oxygen, okay, when these four materials comes in contact with the oxygen, they form into an oxide groups. Okay, they form into an oxide groups. You can see CaO, which is a calcium oxide, SiO2, that is a silicon dioxide, Al2O3, that is aluminum trioxide, ferrous trioxide, magnesium oxide, potassium oxide, sodium oxide, and then SO3, which is sulfates. So this is how these major raw materials, once these raw materials comes in contact with the oxygen, so they will be having the oxygen also. That is why you are seeing OOO and O2, O3, all these things at the end of the material. Ca represents the calcium. When it comes in contact with the oxygen, it becomes calcium oxide. Silica, Si represents silica. Silica is nothing but a sand. When silica comes in contact with the oxygen, it is called as silicon dioxide, that is SiO2. Likewise. So in general, any ordinary Portland cement consists of this percentage of quantities. So in a cement, that is in an ordinary Portland cement, CaO will be in the range of 60 to 70 percentage. SiO2 will be in the range of 17 to 25 percentage. Al2O3 will be in the range of 3 to 8 percentage. Fe2O3 will be in the range of 0.5 to 6 percentage. MgO will be in the range of 0.1 to 4 percentage. K2O and Na2O will be in the range of 0.4 to 1.3. Again, these are called as alkalis. That means these are the harmful substances that should not be there in the cement. But however, we cannot completely avoid of not having these substances in the cement. So there will be some quantity of the cement. So that percentage should be in between this range. If it is more than 1.3 percentage, then it becomes a problem. I'll talk about what is the problem in the next slide. So, and then sulfates will have in between the range of 1.3 to 3%. So this is typical composition of the cement. Okay, CaO 60 to 67 percentage, and then couple of other oxide compositions and its percentage content in the cement. Okay, now what happens here when these oxides, okay, when these oxides interact with one another in the kiln? Now, if you remember, in the cement manufacturing process, we'll have or we'll collect all the raw materials, and once we collect all the raw materials, we are going to send all these raw materials into the rotary kiln where we the raw materials. Now here what happens, all the raw materials before they are going sent to the rotary kiln, they will be as an independent materials. Okay, they will be as an independent materials. But once all the raw materials are sent into the rotary kiln, they will mix with each other. That means limestone will mix with silica, silica will mix with alumina, alumina will mix with iron, and hence all the compounds or all the oxides will mix with each other in the rotary kiln. So when these oxide compositions or when these oxides interact with one another, okay, when these oxides interact with one another in the rotary kiln at high temperature, they used to form a complex compounds. Okay, they will form a complex compound. So once you burn all these raw materials or once you burn all these oxide compositions, they will react with one another and then they'll produce some other complex compounds. Okay, they'll produce some other complex compounds. And those complex compounds, okay, those complex compounds are identified by a scientist called R.H. Bogues. Okay, those complex compounds are identified by a scientist called R.H. Bogues, and hence they are called as a Bogues compounds. Okay, and hence they are called as a Bogues compounds. Now, what are these Bogues compounds? I'll discuss in the next class. I mean, in the next slide. So here, what we need to understand is initially we'll have the raw materials, and once these raw materials comes in contact with the oxygen, they'll convert into the form of oxide compositions. Okay, they'll convert into the form of oxide compositions. Now, again, once these all oxides mixes with one another or interacts with one another in the kiln, they will form a more complex compounds. And these complex compounds are majorly identified by a scientist called R.H. Bogues, and hence they are called as a Bogues compounds, and he is the Bogues. Okay, he is the R.H. Bogues. So since he had identified these complex compounds, upon his name, we are going to call it as Bogues compounds. So proportions of these oxide compositions, you can see here. So proportions of these oxide compositions are the ones which are going to influence the properties of the cement. So why we are getting different types of cements like ordinary Portland cement, rapid hardening cement, quick setting cement, extra rapid hardening cement, sulfate resistant cement? It is because when you change these proportions, okay, when you change these proportions, it indicates or it is responsible for influencing the various properties to the cement. Okay, various properties. So when you change the proportion of the materials, then we'll get a different type of cement. Again, you cannot just like that, you cannot roughly change the composition. It should be following certain code standards. That is why whenever I was discussing the different types of cements, I had given the code book for that also. I mean, I have given the proper code book which you can refer. So you have to go to that code book, or you have to refer the code book, and based on the code book, you have to change these compositions. Then only that particular cement will get produced. All right, fine. Now let's understand about these Bogues compounds. So there are basically 4 Bogues compounds that are available. First one is called as a tricalcium silicate. Before here I could show uh, just the first one, but let me write this. The first Bogues compound is called as a C3S. The second Bogues compound is called as a C2S. And the third Bogues compound is called as a C3A. And the fourth Bogues compound is called as C4AF. So we'll talk about each one of these one by one, but these are the 4 Bogues compounds. So how these Bogues compounds are getting formed? These Bogues compounds are getting formed when the oxides, okay, whatever the oxides that are available in the rotary kiln, when they mix with each other, okay, one oxide when they interact with another oxide, then these Bogues compounds are getting formed. So how these oxides are coming into picture? These oxides are coming into picture because of the raw materials, that is limestone, lime, silica, that is Si, alumina, that is A, and ferrous oxide. Lime, silica, alumina, and ferrous oxide, that is FeO, or ferrous, you can say. So when these compounds, lime, silica, alumina, and iron ferrous, comes in contact with the oxygen, okay, when these compounds comes in contact with the oxygen, they will convert into the oxide compounds. Okay, they will convert into oxide compounds. And then these oxides, we have different oxides like CaO, SiO2, Al2O3, all these oxide compounds are there, right? I have just shown you all the oxide compounds. So when these oxide compounds interacts with one another in the rotary kiln, they are going to form a complex compound. And those complex compounds are called as Bogues compounds. And what are the Bogues compounds? These 4 are the Bogues compounds. C3S, C2S, C3A, and C4A. That's how the Bogues compounds are getting formed. So C3S is called as a tricalcium silicate. Okay, C3S is called as tricalcium silicate. C2S is called as a dicalcium silicate. C3A is called as a tricalcium aluminate, and C4AF is called as a tetracalcium aluminoferrite. Okay, tricalcium silicate, dicalcium silicate, tricalcium aluminate, and tetracalcium aluminoferrite. Okay, we'll talk about each one of these. Fine. So let us first focus on understanding the tricalcium silicate and what is the importance of that one. So tricalcium silicate, the chemical formula of tricalcium silicate is 3CaOSiO2. This is the chemical formula for tricalcium silicate. So it can be called as a C3S also, and we have one more name for that, which is halite. Okay, you can also call it as halite. So C3S or halite or tricalcium silicate or the chemical formula. Usually in cement, the halite content will be 45 to 60%. Okay, in C3, I mean in cement, in standard cements, that is ordinary Portland cement, the halite content, that is the C3S content, will be between 45 to 60%. And it is something which is responsible for the early strength. Okay, it is something which is responsible for the early strength. That is, whatever the strength that you are going to get at the end of 7 days, that strength is majorly because of C3S compound. Okay, that strength is majorly because of the presence of C3S compound. So what is the composition of C3S in the cement? It should be 45 to 60%. And the size of the C3S compound will be 20 to 50 micron meter. Okay, 20 to 50 micrometer or micron meter. So it's a very, very small size. And it liberates heat during the early stages of hydration. It is not just liberating the heat, it liberates a lot of heat. Okay, once when you take the, suppose if you take a cement bag, and people will say that don't keep your hand in the cement bag. So what happens, what will they tell is, if you keep your hand in the cement bag, your hand will get certain kind of itching, or your hand will get certain kind of allergy kind of things. So how that is happening? So are there any reactions that are happening inside the cement bag? Yes, the reactions are happening. So what is that reaction? That reaction is the hydration of cement. Okay, again, the hydration of cement is a different concept. So it is because of the liberation of heat in the cement. Okay, it is because of the liberation of heat in the cement. So due to this liberation, it is responsible for the early strength. And this is something it hardens very rapidly, or it hardens at a fast rate. and it requires 24% of the water content. Okay, if you add 100% of water to the cement, 24% of water will be taken care by the halite or will be absorbed by the halite content, and they will be visible as a light gray crystals. Again, these are not visible to the naked eye, they are the microscopic images. Okay, when you see the cement in the microscope, again, it's not a normal microscope, it's like scanning electron microscope, SEM, we'll call it as. So they will be available in the form of light gray color crystals. And when you cool these C3S content below 250 degrees centigrade, it evaporates into the atmosphere. It decomposes into the atmosphere. Okay, so that's one problem with C3S content. So if you cool the C3S content below 250 degrees centigrade, it decomposes. You will not find C3S content in the cement. Okay, so cement with more C3S content is better for cold weather concreting. So what type of cement we use in the cold weather regions? We use rapid hardening cement or quick setting cement. So what will be there in the rapid hardening cement or quick setting cement? C3S content will be more in such kind of cement. Okay, C3S content will be more in such kind of cement. So rapid hardening or quick extra rapid hardening, why it is happening? It is because of the presence of the C3S compound. Okay, it is because of the presence of the C3S compound. So that's the importance of tricalcium silicate. And the next one is dicalcium silicate. So the chemical formula of dicalcium silicate is 2CaOSiO2. It is also called as a C2S, and it can also be called as a belite. Okay, it can also be called as belite. So the proportion of belite compound in the cement should be 15 to 30%. Okay, the proportion of belite compound in the cement should be 15 to 30%. And it gives the strength, or it is responsible for the strength, whatever the strength that you get after 7 days, that is because of the C2S compound. Okay, whatever the strength that you are going to get after 7 days, that is because of the C2S compound. Whatever the strength that you are going to get before 7 days, that is because of the C3S compound. So before 7 days, C3S compound, after 7 days, C2S compound. That is why it gives latest strength. Again, the size of this also is almost similar to C3S only. That is 15 to 20 micrometer, and it hydrates and hardens slowly. Okay, it hydrates and hardens slowly. So it need not be very slow. You can say it has 28 days of time. And it produces less amount of heat of hydration, and it requires 21% of the water. So if you add 100% of water to the cement, 24% of water will be taken by the C3S, and 21% of water will be taken care by the C2S compound. And they will be available, or they will be visible in the dark color gray crystals. Okay, they will be visible in the dark color gray crystals. And when you have good amount of C2S content, good amount means in between 15 to 30%. So when you have good amount of C2S content in the cement, they will be resisting the chemical attacks to the cement. Okay, they resist the chemical attacks to the cement. And C3S and C2S forms a compound which is called as a CSH. So when C3S and C2S reacts with each other, it forms a third compound which is called as CSH. So CSH is nothing but calcium silicate hydrate. Okay, CSH is nothing but calcium silicate hydrate. That is what CSH means. So that's something related to the C2S. So now let's talk about the C3A compound, which is called as a tricalcium aluminate. Okay, tricalcium aluminate. So here aluminate will be the major content. In C3S and C2S, silica will be the major content. In C3A, we'll have the aluminate as the major content. And this is the formula for aluminate, tricalcium aluminate, 3CaO Al2O3. Al2O3 is the aluminate content. So it can also be called as a Sealite, where it can have a proportion of 6 to 12% in the cement. Okay, it can have 6 to 12% in the cement. Again, so the reaction of C3A with water is very fast. So basically, when you have high amounts of C3A, you will get a quick setting cement. Okay, you'll get quick setting cement. If you want the cement to set very fast, okay, as soon as cement comes in contact with the water, if you want the cement to get set, in that case, we'll use the cement which contains high amounts of C3A, because C3A is responsible for fast setting. Okay, whenever the C3A reacts with the water, it reacts very fastly, and hence it causes a parameter which is called as a flash setting. Flash setting means Immediately, once the cement comes in contact with the water, within maybe 1 or 2 minutes of time, the cement will get set. Okay, where will you use this kind of cement? I mean, where will you use the cement which contains high amounts of C3A when you are constructing the structures in the water bodies, maybe in the rivers, maybe in the sea or ocean. If you want to construct the bridges in the water bodies, you will go with the cement which contains high amounts of C-lite content or C3A content because it sets very fast. Because in such cases, we need the cement to get set at a very faster rate. So that's why we'll go with that kind of cement in the construction of structures in the water bodies. So such kind of setting is called as a flash setting. So what is flash setting? Immediately, once the cement comes in contact with the water, the cement paste will get set. That immediate setting of cement is called as flash setting of cement. Okay. Now, how to prevent the flash set? So do you need flash setting in all the cases? No, we don't need. Suppose, let's say you are constructing the structure, you are constructing your own house. Do you want the cement to get set at a very faster rate? No, we do, there is no requirement for that. So how will you prevent this flash set? This is where will come into picture. So I was telling that gypsum will be added in the cement manufacturing unit itself. So why gypsum is added? To avoid the flash set. But in the cements which contains high amounts of C3A, so in such cements, gypsum will not be there. Okay, in such cements, gypsum will not be there. Whatever the ordinary cements that we are using, that is OPC, PPC, PSC, in all those cements, gypsum will be there. And that is why the cements will not set very fast, or the concrete will not set very fast. It takes some minimum 8 to 10 hours of time to get the initial setting time. So we have two types of setting times to the cement. One is called as initial setting time, and the second one is called as a final setting time. So initial setting time for any cement should be 10 hours. Okay, 10 hours is the initial setting time. So why that 10 hours it is taking? It is because of the presence of gypsum. So if you add gypsum to the cement, it prevents the flash setting to the cement. And remember, gypsum is not something which contributes to the strength. There is no role for gypsum in the strength property. So the only role for gypsum is to increase or is to make sure the flash setting should not happen at a faster rate. Okay, to avoid the flash setting, we'll use gypsum here. Okay, again, the gypsum dosage should be 2 to 3%. That's the standard dosage. We cannot go beyond that. And gypsum will be available in the form, C3A will be available in the form of small dark inclusions, like a small dark circles, it will be like that. And it releases high amounts of heat. And if you take care of, if you observe the water absorption for this one, it is almost taking 40% of water. So when you add water to the cement, that is 100% of water, 40% of water will be taken care by the C3A only. 24 by C3S, 21 percentage by C2S, and 40 percentage, which is the maximum for C3A. That is why it sets very fast. Okay, that's also one of the reasons. And the last one is a C4AF, which is called as tetracalcium aluminoferrite. So in C4AF, we have the calcium content, we have the alumina content, and we also have the ferrous content, that is iron. Okay, calcium, alumina, ferrous. And it is represented with the formula C4AF, and it can also be called as a phyllite. F represents a ferrous here. Fe represents ferrous. So that is called as phyllite, and the phyllite content should be 6 to 8% in the cement. Okay, 6 to 8% should be the C4AF content in the cement. So it hydrates very rapidly, and the final setting, whatever you are going to get to the final setting of the cement, it is because of the C4AF, and it is also responsible for the strength development at the initial stage, not at the later stage. It is at the initial stage. And whatever the color that you are seeing to the cement, that color is majorly due to the C4AF compound only. The gray color to the cement or ash color to the cement, it is because of the presence of C4AF. If you see the cement in the white color, it indicates it doesn't have enough quantity of phyllite content or C4AF content. If you observe the cement to be in the gray color or the regular gray color, that indicates it has enough quantity of C4AF content. So whatever the color that you see to the cement, it is all because of the C4AF compound. And they look as the bright interstitial materials. Okay, they look as the bright interstitial materials, and it is more stable than C3A. Okay, it is more stable than C3A. So these are the couple of things that you need to remember when we are going to focus on the Box compound, C3S, C2S, C3A, and C4A. Now here, this graph talks about the strength role or the role of the Box compounds in attaining the strength to the cement. Okay, the role of Box compounds in attaining strength to the cement. Now, if you see C3S, C3S is something which is playing a major role in attaining strength to the cement. Can you see the graph here? So on the y-axis, you have the compressive strength. On the x-axis, you have the number of days or age of the concrete. So as the age of the concrete is getting increased, okay, as the age of the concrete is getting increased, the compressive strength, which is responsible for C3S, is also getting increased. And C2S is also something which is responsible for the increase in strength of the cement. So here you can say that by using C3S and C2S, or you can also say in this way, C3S and C2S are responsible for the strength to the cement. Now, as I was telling earlier, C3S is responsible for the early strength and C2S is responsible for the later strength. That means whatever the strength that you get before 7 days, that is strength is basically due to C3S compound. Now you can see the graph here. Where that graph had started, it started at before 7 days only. Okay, before 7 days only, it reached 30 megapascals of strength. That means whatever the initial strength, that is before 7 days, whatever the strength that you are getting, it is majorly because of the C3S. But when you take C2S, it starts attaining the strength after 7 days. That means somewhere in between 7 to 28 days, it started attaining the strength. You can see the curve starting of the C2S compound. It is starting somewhere here at this particular point. So that means C2S is responsible for the later strength and C3S is responsible for the early strength to the cement. Okay, that's how you can say. And C3A and C4AF, as we are discussing in the previous slides, they do not have any role or they do not have a maximum role in getting the strength. So hardly they are getting maybe 5 or 6 megapascals of strength. You can see. So in between 0 to 10 megapascals is the role of these compounds. So what is the role of C3A? C3A is majorly for the flash setting of the cement. And C4AF is majorly for the color to the cement. Whatever the gray color that you get to the cement, it is all because of the C4A. So that's how the role of C3S, C2S, C3A, and C4AF in the strength properties of cement will play. Now, there are also other minor compounds that are available in the rotary kiln, and those minor compounds are called as alkalis in the cement. Suppose if you remember, I was showing the chemical composition of the cement. So in the chemical composition of cement, I was showing you, let me show you that. I was showing you the last two things, that is alkalis in the cement, that is K2O and Na2O. Yeah, these ones, K2O and Na2O. I have represented it as alkalis. So I was telling that alkalis are not good for the cement. Okay, alkalis are not good for the cement. They are something which makes the concrete or which makes the cement as a poor quality cement. Again, when they are available in between these percentages, there is no problem. There won't be much effect. But when the percentage of alkalis goes beyond 1.3 percentage, then the problem comes. Okay, then the problem will be there for the cement. So that's what we are talking about. Some other compounds are also available. Apart from these 4 Box compounds, that is C3S, C2S, C3A, and C4AF. Apart from these 4 Box compounds, we also have another minor compounds, and those minor compounds, among those minor compounds, 2 of the most important minor compounds are K2O and Na2O. That is potassium oxide and sodium oxide. So these 2 compounds or these 2 minor oxides are called as alkalis in the cement. So when you have alkalis in the cement, what does they do? They reacts with the aggregates and hence they produce the products of the reaction causes disintegration of concrete. That means concrete will lose strength or concrete patches will form on the surface. So that is called as a disintegration. So when you have high contents of alkalis in the cement, so if you are seeing the patches or if you are seeing the surface cracks, the one reason could be the alkali content will be high in such kind of cements. Okay, that's what the alkalis will do in the cement. So, and it also the strength gain to the cement. Okay, it also affects the. The question is, how will you determine alkalis in the cement? So there is one equipment which is called a spectrophotometer. So when you take a sample of cement and when you observe under the spectrophotometer, you will be able to find the K2O and Na2O compounds. Again, this is not something which we need to bother. This is something which will be bothered by the cement manufacturing units itself. They will take care of this one. But again, if somebody asks you, how will you determine the alkalis in the cement? There is one equipment which is called as a spectrophotometer. That's how you can define the, or you can determine the alkalis in the cement. Now, the thing is, how will you identify the Bogues compounds? Okay, how will
Excuse
you
me, sir.
identify the Bogues compound? Yeah, please go.
Hello, sir. Sorry, sir.
Yeah,
In
please
the
go on.
the main components of lime, silica, alumina, and iron. From these main
Yeah,
materials, when we are mixing in the rotary kiln, the other
yes.
components will be mixed. As you said, C2S, C2S, and C3S, and C3A or
No,
C4A.
they will get formed. They will get
They'll get
formed.
formed, automatically formed.
C3S? Yeah, yes, yes.
Okay, okay. So my question
It's
is,
something like, suppose yeah, please go on. Please go.
sir, when we are dumping the materials when we are dumping the materials in the roller, which you showed me yesterday, the photograph of
Okay,
the manufacturing
okay,
cement. So
okay.
are there any controls, like, okay, this batch we need to mix this one, or are there any controls?
Yes, we do have that. So I was telling in the last session that everything, I mean, whatever the materials that has to go inside the rotary kiln, they all will be maintained by the computer software. I mean, a software will be there, so it will be generated by the software. So in the software, we'll give the input. Suppose, let's say you take L&T cement. In L&T, I mean, L&T company will not manufacture only the ordinary Portland cement. It manufactures the PPC, PSC, and other types of cements also. So how they are able to manufacture the different types of cements based on the compositions that they are going to change. So when they are using high amounts of calcium, one type of cement will come. When they are using high amounts of silica, they will get some type of cement. So it depends on the composition. Yes, we do have that process.
Okay, sir. All right, sir.
Yeah. I hope I have answered your question.
Yes, sir, I understood. Thank you.
Yeah, fine. Yeah, fine. So it's something like, suppose if you take a water and if you want to make that water as a salt water, what will you do? You will add some amount of salt. If you want to make that water as an
Sir, your voice is not audible.
yeah, I think there was some problem. I hope you are able to see the screen.
Yes, sir. Now
Yeah.
I can.
Yeah, fine. So what I was mentioning is, suppose if you want to make a water as a salt water, so let's say you just want to make a little amount of salt. Suppose when you get, when you get some throat infection, in these cases, people will say that, or the elders will say that you try to use salt water and you try to gargle the salt water. So there you can have that soft salt water. You can take that salt water into your body. There won't be any problem. But when you add huge amount of salt to the water, what will it become? It will become much more salty water. So here what we need to understand is based upon the material that you are adding. If you add sugar to the water, it will become a sweet water. If you add salt to the water, it will become salt water. If you add certain kind of mirchi powder into the water, it will become some other types of water. So based upon the material that you are using, that's one scenario. And the second thing is based upon the quantity of the material that you are using. So you can add salt water and you can drink salt water, but you cannot add some one bag of one packet of salt to the water and you cannot drink that water. So that's where similarly the composition of the cement manufacturing will also depends on the composition of the materials. So when you add the compositions in a proper way, then you will get one type of cement. When you decrease one composition and when you increase one composition, then you will get a different type of cement. So it all depends on the need of the cement. So which cement is majorly used in the real-time scenarios. Based on that, the companies will have the change in the values of the compounds, and then they are going to produce those cements. So that's how the cements will get produced. Yeah. So the next thing is, how will you identify the box compounds? So in order to identify the box compounds, suppose let's say I have given you a sample of cement. Okay, I have given you a sample of cement and I asked you to determine the box compounds. Tell me how much percentage of C3S is available, tell how much percentage of C2S, C3A and C4AF is available. So it's not something which can be visually seen. Okay, it is not something which can be visually seen. So we need to use an equipment which is called as XRD, that is called as X-ray diffraction instrument. So what we will do in this instrument is we'll take a sample of cement and we'll keep it inside the machine. Okay, and then we'll observe that. So this XRD will give us the results. So based upon the results, we can identify. So they'll give it this kind of image. XRD will give this kind of image, something like X-ray only. Suppose when you go to your doctor and if you have some problem in, so let's say you have some problem in the hand or a fracture had happened to your hand. So what doctor will suggest? Doctor will suggest to first go and get the X-ray. So what does X-ray consist of? It gives the image what is there inside the bone or what happened to the bone, which we cannot visually see with the naked eye. Similarly, XRD is also one such instrument where we can see the internal composition of the cement. So that internal composition, when you see a cement sample inside the XRD, okay, you will get this kind of image. Now, in this image, you will have different compounds. And these compounds, it is important to understand what compound is which one. So if you see C3S, okay, if you see C3S, they are available in the form of a huge hexagonal crystals. C2S is something like small dark inclusions, dark inclusions. I was telling all these things. That is where these things will come into picture. Anyways, I still have to discuss about these compounds when we are talking about the hydration of the cement. So that we'll talk in the next class probably, or if possible, I'll try to finish it up in this class only. But this is how the compounds will get identified once you send the sample through the XRD instrument. That's how you'll get. So C3S basically available in the large irregular crystals. You can see all these crystals, whatever that you see, they're all called as C3S. And C2S are basically in the form of a small round color materials or round crystals. Again, they are not purely round materials, they are round crystals. And then C3A and C4AF, they are basically available in the form of powder. You can see on the surface of material, you can see a small powder kind of materials each and everywhere. So all that powder is called as C3A and C4AF. So that's how you can identify the box compounds under XRD instrument. Right? Again, we need to discuss much more about that. So again, the percentage of box compounds. So this is how you can calculate the percentage of box compounds. So if you want more details about this, you can refer this particular link. So again, this is not something related. This is something which is related to mathematical equation or mathematical calculation, but this is something which is precise. Okay, when you go with XRD instrumentation or XRD of the cement, this is where you'll get the precise content. But if you want to find out the quantity, then you have to go with this formula, the percentage of the C3S, percentage of C2S, C3A, and C4A. Here C represents calcium, S represents silica, F represents a ferrous, SO3 represents sulfates, okay, and C3A represents the tricalcium aluminate. Okay, that's where you can find out the percentage of box compounds that are available in a sample of cement. Fine. So now let us talk about what are the functions of different compounds. So I was telling that in cement we'll have four major compounds, four major raw materials. One is called as lime, second one is silica, third one is alumina, and the fourth one is iron or ferrous oxide. Let's understand what is the function of lime in cement, and then what is the function of silica in cement, function of alumina in cement, and function of ferrous oxide in the cement. Let us understand this. And then we'll talk about the hydration process in the next class. So what is the function of lime in the cement? So basically lime will occupy major proportion in the cement. Okay, it is a major constituent in the cement. And when you use more amount of lime, it becomes unsoundness to the cement. That means cement will not have proper, cement will not give better properties when you use excess amount of lime. So it's something like, suppose in the olden days, maybe our grandparents or great grandparents, they'll use this lime to eat. I don't know whether it happens in your scenario or not, but my great grandparents used to eat lime when they used to eat the pan masala, these kind of things. The pan leaves will be there, right? The betel leaves. So when they're eating the betel leaf, they'll apply the lime on the surface of the betel leaf. So what happens is when you apply excess amount of lime on the betel leaf, our mouth will get swollen out. Our mouth will become certain kind of wounds will be appearing on in the mouth. So that's because excess amount of lime. So similarly, in concrete structures also, when you use excess amount of lime in the cement, it makes the concrete structure as an unsound material. That means it will not have enough properties to the cement. Okay, it will not give enough properties to the structure or to the cement also. So deficiency, when you apply less amount of lime or when you have less amount of lime content in the cement, it decreases the strength. Both way it is a problem. Excess will lead to unsoundness. Deficiency will lead to decrease in the strength. Both way it is a problem. So you have to be very careful in maintaining the proper limestone content in the cement. So what is the limestone content? Approximately 60 to 67% is the composition of lime that should be there in the cement. And then the silica content, basically silica is nothing but the sand. So when you add silica to the cement, it gives strength to the cement. Again, when you add excess amount, it gives excess strength, but the problem is the setting time will get prolonged. So you can add more and more amount of cement, more and more amount of silica in the cement. When you add more and more amount of silica in the cement, you will get better strength. But the problem is you will get the delay in the setting time. The cement will not get at a faster rate. Maybe you need some 15 hours or 20 hours for the initial setting time itself. That's something the problem with silica. And then the function of alumina is it makes the cement to set very fast. That is called flash setting. I was talking about this one in the C3A discussion. So when you have high amounts of alumina content, it makes the cement to set very fast, which is called as a quick setting. And when you make sure the excess amount of alumina is added, it reduces the strength. Okay, when you add in a sufficient quantities, there is no problem. But when you add excess amount of alumina, it reduces the strength to the cement. That's something which we have to bother. And the last one is the function of the ferrous oxide. Again, C4AF. C4AF is majorly for the color to the cement. So whatever the color that you get to the cement, the gray color or ash color, that is all because of the ferrous oxide. And it plays little amount of role in the hardness of the cement, and it also plays some amount of role in the strength to the cement. But the major role will be to the color to the cement. And it also helps the fusion of the raw materials. So when you want to mix all the raw materials, if all the raw materials are mixing properly, that is because of the presence of ferrous oxide. So when you have the ferrous oxide, enough quantity of ferrous oxide in the cement manufacturing process, all the materials, whatever the raw materials that you are going to use, this ferrous oxide will help us to fusion of the all raw materials. Fusion means proper mixing or proper intimate mixing, we'll call it as. So intimate mixing of all the raw materials will happen because of the presence of ferrous oxide. So this is how the functions of lime, silica, alumina, and ferrous oxide will take place in the cement manufacturing process. And these are the functions and importance of all these raw materials. So in the next class, what we'll discuss is we'll be talking about a property, not this one. We'll not be talking about test on physical properties. So we'll be talking about a thing which is called as hydration of cement. Okay, in the next class, we'll focus on hydration of cement and the setting of cement. Okay, and then we'll go with the physical property tests on physical properties of cement, which are laboratory tests, and then the field tests we'll be talking about. So we'll be completing all this scenario one by one in the next class. So in the next class, we'll be focusing majorly on the hydration of cement, which is the most important one. To understand the chemistry that is involved in the cement, then we need to understand the hydration process. I was telling that heat will get evaluated, more amount of heat will be evaluated, less amount of heat will be evaluated. So we need to understand that how that heat is getting evaluated. So that reactions we need to understand. So next class will be mostly with the chemistry only. So if you are bored at chemistry, there is no option. We have to understand that chemical reaction process. Then only we'll be understanding the in-depth details of the chemical process that happens in the cement part. So that's from my end. If you have any doubts in this particular session, you can unmute and you can ask the doubts.
No, sir, up to now it's okay, sir. Comfort. Once I go through the videos again, then if anything, then I will ask in the next class.
Sure. Sure. I'll just share the recorded videos, maybe in half an hour. By 7 o'clock, I'll share maximum. You can have a look into
Okay.
that. Meanwhile, you can share me your email ID so that I can give the permission to your email ID to watch the video.
Okay, sir. I'll do
Yeah,
that.
sure. Yeah, sure.
And even
Absolutely.
the books as well, right, sir?
Yeah,
And
I'll
sir,
share that.
yeah, sir,
Yeah.
I want to ask you one thing, sir. Out of the class, that in the last 3 days session, you told that we can look in your research papers or something like that. You was telling us, right,
Yes,
sir?
I'll share those research papers also.
Okay, thank you so much, sir.
Yeah, sure. See you.
Sir, what is this Vidyapeetham? Something is showing that?
It's the university where I do my PhD.